Greetings, M squared here, and we are going to solve some more equations that have rational exponents. So this is like basic level. We aren't going to use logarithms or anything. We'll always be able to use one of our exponent rules to either get them in the same base or simplify it so that we can solve it. So no logarithms here. So our first step is to get the bases the same. So when I look at this problem, I see a 5 as a base, a 25, and a 5. So that's my hint that 5 should work, because I know that 25 is 5 squared. So you'll see over here we get a 16 and a 64. So you want to make sure that you know, that you recognize that this is 4 squared and that this is 4 cubed. So they're not going to really trick you. You're going to use a base of 3 or 4 or 2 or 5, sometimes 6, but usually it'll just be those bases, 2, 3, 4, 5. So the first thing I do is change it, because I can't use my exponent rules until the bases are the same. So I'm going to rewrite this one, 5 to the x over 9 times 5 squared. Now 5 squared is 25, so I didn't change the number, I just changed how it looks so it has the same base. And then I'm going to say x over 2 equals 5 to the 8th. And now if the bases are the same, I can add the exponents. But first, I need to clean this up a little bit, because this is my power rule. So I need to use my power rule first before I use my product rule. So I'm going to say 5 to the x over 9 times 5, and I'm going to multiply. 2x divided by 2, or 2x over 2, is just x, right? 2 times x over 2 equals 2x over 2. The x's cancel, and the 2's cancel, and I get an x. Okay? And so then it equals 5 to the 8th. So the rule, remember, x squared times x cubed equals x to the 5th, because if the bases are the same, I add exponents. 2 plus 3 is 5. It's the same thing over here. If the bases are the same and I'm multiplying, I'm going to add those exponents. So I'm going to get 5 to the x over 9 plus x equals 8. So, I'm sorry, that is not 8. Let me redo that. That is 5 to the 8th. Skipping a step here. Now that the bases are the same, and this is an equation, these have to be equal, I know that this would have to be equal to 8. Otherwise, these expressions wouldn't be equal. So now I kind of change it to an exponent equals exponent. I change it to x over 9 plus x equals 8. And from here, you should just go back to your linear equation rules, right? No more bases, no more exponents. I'm just saying this equals this. So there's different ways you can do it. I like to eliminate fractions first, so I use the method where you multiply every term by the common denominator. You could get a 9/9 x and add those, but I'm just going to multiply that by the common denominator because I think that's a little easier. So going up here now, the 9's cancel. That's why I do it, to get rid of the fractions. That's why I multiply by the common denominator. So I'm just left with 1x, or just x, plus 9x equals 72. Because 8 times 9 is 72. So I end up getting 10x equals 72. So x equals 7.2 if you do that in your calculator. Sometimes they might want it as a simplified fraction, so you can reduce that. That's 36 over 5. Either one. Okay, next one. First thing I check, are the bases the same? No, the bases are not the same. But I know that 16 equals 4 squared, and I know that 64 equals 4 cubed. So I'm going to use those instead. So I'm going to rewrite this as 4 squared equals 4 cubed, and then put the exponent that they already gave me there. All right, so now I use the power rule. So it's going to be 4 to the 2 times 3x minus 3 equals 4 to the 3x plus 2. And then I know that since these are equal and the bases are the same, that those exponents have to be equal to each other. So I'm going to rewrite that. 2 times 3x minus 3 equals 3 times x plus 2. So that's a linear equation again. Got to use my distributive property. So I'm going to say, right, 6x minus 6 equals 3x plus 6. Then I'm going to subtract 3x from both sides. And at the same time, I move the variables to the left side. I'm going to move my constants to the right side. And I'm going to get, after I do that, and those cancel out, I'm going to get 3x equals 12, so x equals 4. Now you can always double check it by putting that 4 back in there. And I showed you that in the other video. But it's always a good idea to plug it back in and see if you get the same expression. Okay, we'll try another one. This one is a different rule because it's dividing, so we're going to use our quotient rule. But before we do that, our very first step is, are the bases the same? That's a 27, that's a 3, that's a 1. That's a problem. We got to have all the bases the same. So I know that 27 is equal to 3 cubed. I know that 1 is equal to 3 to the 0. So I'm going to change those other things to 3's. So I got 3 cubed to the 1/5 over 3 to the x over 5 equals 3 to the 0. Now I can use my power rule. So I get 3 to the 3/5 over 3 to the x over 5 equals 3 to the 0. And then I can subtract. So my quotient rule says that if I have an exponent in the top, the bases are the same, I can subtract the exponent from the bottom. And then I would get 3 to the 0. So that means if these are equal, these have to be equal. So up here I get 3/5 minus x over 5 equals 0. Again, I'm going to use my common denominator rule. So I'm going to multiply by 5. So I'm going to get 3, because those cancel out, minus x equals 0. And if I add x to both sides, I get 3 equals x. Alrighty, isn't this fun? Okay, next. Now notice the bases aren't the same, and there is no way I can get 3 to be the same as a 5. So I have to use a different rule. I have to use my rule that says if I have a product and it's raised to a power, that's the same thing as having each of the powers on them separately, except I'm going to go backwards. I have it kind of like this. I'm going to use it like that. So I'm going to take my 5 equals, and instead of saying 3 to the 1/2 times x to the 1/2, I'm going to say 3x to the 1/2. So that's the first thing I do. And then I have to remember that I got to get x alone. So in order to get rid of this, I have to do the opposite of square rooting. Remember, that's a square rooting. The opposite of that is squaring. If I do it to the right side, I have to do it to the left side. So that's going to get rid of my power. So I get 25, which is 5 squared, equals, and then these cancel out because 2 times 1/2 is 1, and 3x to the first power is just 3x. And then I just get x alone by dividing by 3 because that's the only thing preventing it from being alone. So 25/3 is my x. All right, last one. So are the bases the same? No. Can I get them the same? Yes. Well, this isn't 4 to a power. This is, remember we had 4 squared is 16 and then 4 cubed is 64. So I have to break them down to 2's. So I know that 2 squared is 4. I don't need parentheses, but it started so. I know that 2 to the 5th power is 32 because 2 to the 4th power is 16 times 2 is 32. So that's 2 to the 5th power. So I have 2 to the 5th and then to the negative x over 5. So this is my power of a power rule. When I multiply there, I get 2 to the negative 5x over 5 equals 2 squared. Well, 5 divided by 5 cancels, so I end up with 2 to the negative x equals 2 to the 2. And if they're equal, these two have to be equal. So I set them equal. Negative x equals 2. And if I divide by negative 1 on both sides, I get x equals negative 2. So my answer is negative 2. Okay, so good luck with that. You've got to know your exponent rules. You've got to always remember to put things in the same base unless it's one of these rules. And then just remember all the little steps because there's a lot of little steps there. So good luck with that. M squared, signing out.